Hello, in this lecture, as we were doing the previous lecture, some questions on inverse Laplace transform. In this lecture also, we are going to continue with the problem solving on Laplace transforms. Okay, so let us do a few more questions now, and then we shall take some another topic. Okay, okay. So let us try to solve it. Okay. So let me solve this question. Okay. So here it is. Try to solve this question. This is 1 upon. Try to find the Laplace inverse of 1 upon s into s square plus a square. How to solve this particular Laplace inverse? So one of the ways can be to see that it is Laplace inverse of fs into gfs, where fs is simply 1 upon s and your g of s is simply 1 upon s square plus a square. And if you want to take the Laplace inverse of capital Fs, then you will simply get it as 1. And if you want to take the Laplace inverse of g of s, you will simply get it as, I think, 1 upon a sine of at. Okay, so this is your Laplace inverse. So this is equal to what? This is equals to the convolution of f into g, which is equivalent to writing integration from 0 to t. And this is, I think, e की power. So it is simply 1. And then you can write sine of x minus of, or sorry, you can write t minus of x, and I think there was dt here. If you remember, this was your convolution of f into g, convolution of f and g. So convolution of f and g is simply this. And here, if you take this integration would be what? This integration would be simply cos of t minus x with a negative sign from where to where? From 0 to simply t. That's okay. There is a also, no? Oh, my mistake. So a would also come here, and a would also be divided here. So 1 upon a is already here. So if I divide this entire thing, I'll also get a minus 1. So I'll get, I think, this I can write minus 1 upon a square. If you write cos t instead of, there is some mistake of what I think this was some, sorry, my mistake. This was x. So it was x here. So if I integrate with respect to x now, then galti kar rahe, right? That's a पहले नहीं. If I want to integrate it with respect to x now, so what I'll get? यही था ना शायद. देखो, if you remember, this was f in f star g was, I think, integration from 0 to t f of x into g of t minus x dx. This is how I used to write. Okay, so if I use that, this integration then would become what? Cos of a t minus x divided by cos of a t minus x divided by, and there is a negative sign because of sine, and again a negative sign because of the because a is multiplied here. So this a would get absorbed, and if you write t first, so you will get 1 upon a square is fine. You will get 1 minus cos. If you write 0 here, so you'll get. So this should be the answer. Is that clear? So you'll get an answer as 1 upon a square into 1 minus of cos of. If I've made a mistake somewhere, let me see. चाहिए तो नया. ठीक है. Is that clear? ये चीज समझ में आई कि नहीं आई? Okay, good. चलो. अभी now let us do a few more questions. Error functions we've done much of the things. Now let us try to solve solution of a differential equation. So if you want to solve a differential equation using a Laplace transform, so how to go about it? So let us say if I want to solve d2y upon dt square plus yt is equal to 0 with the condition that y0 is equal to 0 and y dash 0 is equal to 1, then how to solve it? So So if I want to take, I'll take the Laplace transform of both on the on both sides. That is Laplace transform of d2y upon dt square plus Laplace transform of yt would be simply Laplace transform of 0. And what is Laplace transform of double derivative? It is equals to s square Laplace transform of y minus s into y of 0 minus y dash 0 plus Laplace transform of y, and it is equal to what? 0. Laplace transform of 0 is simply 0. So it is equals to this is, let's say this is Laplace transform of y is capital Y minus s. What is y0? It is given to be 0. And what is y dash 0? It is given to be equal to minus 1. So it is y plus 1 plus ys is equals to, that implies what? Your y as a function of s, that is the Laplace transform of y, is simply equals to 1 minus of no, it is equals to 1 upon 1 plus s square. And what would be Laplace inverse of ys? This will give you the solution, which is yt, which is equivalent to writing Laplace inverse of 1 plus s square, which is simply equals to sin t. I hope it is clear. So this is how you solve the initial value problems using the Laplace transform. Okay. Now, if you have a some term also, then also you can take a Laplace transform. That also you can do. So, for example, if I want you to find the Laplace transform of, if I want to find the solution of initial value problem, which is given by d2y upon dt square minus 3 dy by dt plus 2y is equals to what? It is equals to 12 e to the power minus 2t, given that y0 is 2 and y dash 0 is 6. Then how to find the solution for this using Laplace transform method. So I'll take a Laplace transform on both of the side. And if I take the Laplace transform, so I'll now write it as s square y minus s into y0, which is simply 2s, and then minus y dash 0, which is simply 6. And then what is the Laplace transform of dy by dt? It is equals to s into ys minus y0. What is y0? It is simply 2 plus 2 times Laplace transform of y is simply capital Y. And what is the Laplace transform of this? This will be 12 upon s plus 2. I hope it is clear. I have taken the Laplace transform on both of the side and directly have written the result so that we can save our time. And if I add these terms up, s square, then I have this minus 3s here. See, s square is there, and this is, अच्छा ये ys है ना, अच्छा s into ys भी तो है. So this is minus 3s, then plus I think 2 is here, and this entire thing is equal times 5 minus this term 2s. Is that clear or not clear? Because this minus 6 plus 6 will get cancelled. See, this will get cancelled. This is minus 6 and this is plus 6. So this will get cancelled and you have this term 12. And if you take this term there, you get plus 2s square plus 4s divided by s plus 2. I'll take that also there. Okay, now if you want to solve it, it will be like y of s would be simply 2s square plus 4s plus 12 upon, this is what? This is, I think, s minus 1 into s minus 2 into s plus 2. And now what you can do, you can use the partial fractions and then you can find what is ys. Using partial fractions, a upon s minus 1 plus b upon s minus 2 plus c upon s plus 2, what it would be. So I'll write here a upon s minus 1 plus b upon s minus 2 plus c upon s plus 2. So what it will be? You have to find it. You find these values of a, b, c's, and then you can simply take the Laplace inverse. So Laplace inverse by s would be simply 8 times e to the power minus t plus b times e to the power minus 2t. Sorry, s minus a, a plus c times e to the power minus 2t. You have to find ABCs from here. This I'm leaving to you as a homework. Find ABCs.